So imagine the most powerful machine a civilization could ever build. It doesn't orbit a star. It surrounds one, wraps around the whole thing and drinks its light. We call it a Dyson sphere. And if even one of them exists out there in our galaxy, we might already be able to find it. So start with our own sun. Every second it puts out nearly 400 septillion watts of energy. Now, you can't really picture that number. Nobody can. But almost all of it is wasted. It just pours out into empty space, in every direction, right? And Earth? We catch less than a billionth of it. Everything we have ever done, every city we've lit, every rocket we've launched, runs on that one thin, accidental sliver. So think about what a civilization could do if it decided to stop wasting the rest. So back in 1960, a physicist named Freeman Dyson asked exactly that. And his logic is simple. Any civilization that keeps growing keeps needing more energy, until one day, the whole planet just isn't enough. And when you hit that wall, there's really only one place left to go, the star itself. Not tap it, not orbit it, surround it, and capture all of its light. Now there's a scale for this, the Kardashev scale, that ranks civilizations by the energy they command. A species that captures its entire star? That's a Type II. And us? We're not even Type I yet. Now, you've seen this in the movies. One giant solid shell, a hollow ball with the star locked inside. But that version can't exist. And not just because we couldn't build it, because it couldn't hold together if we did. No material we know of survives that kind of heat and stress. And the gravity doesn't even work. Inside a solid shell, the pull cancels out to zero, so the star wouldn't hold the shell in place at all. One nudge, and the whole thing drifts, and falls right into the sun it was built to surround. Dyson knew all this. He never meant a solid shell. What he actually pictured was stranger, and it's the only version that could actually exist. So not one object, millions of them, billions. Think independent collectors, mirrors, solar panels, whole habitats, each one riding its own orbit around the star, and all of them together forming a swarm. A slow, glittering cloud that catches sunlight from every angle at once. That is the real Dyson sphere. Not a shell, a swarm. And if you could stand inside it, forget a smooth wall, you'd see a storm of glinting panels running off in every direction. So many of them that the star behind them fades to a soft, filtered glow. So how would you actually build the thing? The problem is material. You'd need more than any civilization just has lying around. A handful of asteroids won't do it. You'd have to take apart an entire planet. And the leading candidate is Mercury. Small, close to the sun, no atmosphere in the way, and loaded with metal. So you send self-replicating machines. They land, they mine, and they use what they dig up to build more machines, and more collectors. And they launch them into orbit. One becomes two. Two become four. And over decades, maybe centuries, that swarm builds itself, feeding on a dismantled world until it slowly swallows the light of the entire star. And the payoff? You'd have the entire energy output of a star, trillions of times more power than all of humanity uses today. Enough to run computers the size of planets. Enough to reshape whole worlds. Enough to finally send ships to other stars. So for a civilization that pulls this off, the limits you and I live inside every single day, they just stop applying. So far, this is all just theory. But a Dyson swarm can't cheat physics, right? It soaks up a star's light, but that energy has to go somewhere, and it comes right back out as heat, a faint infrared glow. So think about what that means. Somewhere out there could be a star that looks strangely dim to your eyes, but lights up in infrared. And that is exactly the fingerprint Freeman Dyson told us to look for, all the way back in 1960. So astronomers have been quietly hunting for it ever since. In fact, one star, nicknamed Tabby's star, flickered so strangely that people seriously put a Dyson swarm on the table. Before ordinary cosmic dust turned out to be the likelier answer. So we haven't found one, not yet. But nothing in physics says we won't. The only things standing in the way are engineering and time. And somewhere out there, right now, a civilization may already be living inside the light of its own captured star. And if they are, then the whole galaxy is quietly glowing with the evidence, just sitting there in infrared, waiting for us to look up and notice the one star that went dark on purpose.